So let's go. Here's a number that should bother you. 200 billion. That's the lower estimate for the number of stars in the Milky Way alone. The upper estimate is closer to 400 billion, and scientists genuinely aren't sure which is right. The uncertainty is larger than most people's entire conception of what a lot means. Now take those stars. We know because the Kepler Space Telescope spent years staring at a tiny patch of sky and counting that the overwhelming majority of them have planets. Not some, not most. Virtually all of them. That gives you conservatively hundreds of billions of worlds just in this one galaxy. And there are 2 trillion galaxies in the observable universe. So here is the question that has quietly terrified physicists, astronomers, and philosophers for 70 years. Where is everyone? The universe is 13.8 billion years old. It has been producing stars, planets, and the raw chemical ingredients for biology for most of that time. The atoms that make up living organisms, carbon, nitrogen, oxygen, phosphorus, are not special. They're forged in dying stars and flung across the cosmos in supernovae. They are everywhere. Organic chemistry doesn't require rare conditions. It requires time and the right elements, and it goes. And there has been incomprehensible amounts of time. The math insists life should be out there. Not possibly, not probably. The math insists on it with the same cold indifference that gravity insists objects fall. And yet, we listen, and we search, and we point instruments worth billions of dollars at the sky in every direction, and what comes back is nothing. Absolute, total, unbroken silence. That silence is the Fermi Paradox, and the longer you sit with it, the more unsettling it becomes. Because every serious explanation for why no one has answered is, in its own way, horrifying. Let's start with time. Because the first thing most people don't appreciate is just how long the universe has been running this experiment before we showed up. Earth is 4.5 billion years old. Life appeared on it within the first billion years, maybe earlier. Complex multicellular life took another couple billion years after that. Humans in our current form have existed for roughly 300,000 years. Recorded civilization stretches back maybe 12,000. We have had radio technology for about 120 years. That is the slice of time during which we have been capable of detecting another civilization or being detected by one. 120 years out of 13.8 billion. Now consider this. A civilization that appeared on any planet anywhere in the Milky Way just 10 million years before us, which in cosmic terms is nothing. A rounding error, a blink, would have had 10 million years of head start. 10 million years to develop technology we can't conceive of. 10 million years to potentially spread to other star systems. And here is the part that should make you stop whatever you're doing. Astrophysicists have run the models on what expansion would actually look like. A civilization traveling between stars at just 1% of the speed of light, which is slow by any optimistic future standard, could colonize the entire Milky Way galaxy in somewhere between 2 and 50 million years. Every star, every planet, every corner of a galaxy 100,000 light years across, in 50 million years or less. The universe has had billions of years to produce a civilization capable of doing that. It should have happened dozens of times over, hundreds of times. The galaxy should be unrecognizably transformed by now. Our solar system should be full of someone else's infrastructure. We should be finding artifacts, signals, structures, evidence, not faint whispers at the edge of detection. Overwhelming, undeniable, everywhere evidence. There is none. Which means something is preventing it. And whatever that something is, it is nearly 100% effective, operating across cosmic timescales against every civilization that has ever arisen anywhere. That's the thing that keeps researchers quiet at conferences, not the silence itself, the consistency of it. Now let's talk about what we've actually tried, because the silence isn't from a lack of effort. Since 1960, the search for extraterrestrial intelligence has been conducting the most sustained and methodical listening project in the history of science. What started with Frank Drake pointing a radio telescope at 2 nearby stars has grown into a global enterprise using some of the most sensitive instruments ever constructed. We have scanned billions of radio frequencies. We have listened to individual star systems for years at a stretch. We have done broadband sweeps of the entire galactic plane. We have expanded the search to optical wavelengths, looking for laser pulses that an advanced civilization might use the way we use fiber optic cables. We have looked for Dyson spheres, the theoretical megastructures a civilization might build around a star to harvest its total energy output, by searching for stars that emit more infrared heat than they should and less visible light. We have used artificial intelligence to sift through data sets so large no human team could review them. In 60 plus years of searching, we have found exactly one signal that looked like it might be artificial: the WOW signal. August 15th, 1977. An astronomer at Ohio State University named Jerry Amen was reviewing a printout of radio data and circled a sequence of numbers and letters so strong and so structured that he wrote one word in the margin with a red pen: Wow. The signal lasted 72 seconds, which was the full observation window. It came from the direction of the constellation Sagittarius. It matched almost exactly what theorists had predicted an extraterrestrial broadcast might look like. It never repeated. In the 47 years since, that patch of sky has been observed thousands of times by increasingly powerful equipment. The WOW signal has never returned. Whether it was alien in origin, a natural astrophysical phenomenon we don't fully understand, or something else entirely, is still genuinely unresolved. One signal in 6 decades, and even that one won't stay still long enough to confirm. The silence is not from not trying. The silence is the answer, and the silence extends beyond radio. In 2015, a team of researchers did something that sounds straightforward but had never been done systematically at scale. They looked at data from the Wide Field Infrared Survey Explorer, a NASA telescope that mapped the entire sky in infrared, and they searched for the heat signatures that a Kardashev Type 3 civilization would produce. A Kardashev Type 3 civilization is one that has harnessed the energy of an entire galaxy. Not a star, not a solar system, a galaxy. That level of energy use would produce an unmistakable infrared signature. Waste heat is thermodynamically inevitable. You cannot use energy without some of it becoming heat, and heat radiates at infrared wavelengths. The researchers analyzed over 100,000 galaxies. They found none. Not one galaxy in 100,000 showing even a hint of galaxy-scale engineering. A few dozen showed slight infrared excesses that warranted a second look, and each of them had natural explanations: dust, star formation, ordinary astrophysical processes. 100,000 galaxies, each one containing hundreds of billions of stars, billions of years of time for civilizations to arise and expand and consume. And in all of it, not a single fingerprint of anything artificial at galactic scale. The silence isn't just in our backyard, it's everywhere we look. And here is where the explanations start and where they each become, in their own distinct way, deeply unsettling. The most optimistic version is that intelligent life is genuinely rare. Maybe not life itself. Life might be common. Microbes might be everywhere. But the jump from microbial life to complex multicellular organisms, and then from complex organisms to intelligence, and then from intelligence to technology, might each involve such astronomically unlikely steps that the total probability across the chain collapses almost to zero. We got lucky. We won a lottery with odds so extreme that across 2 trillion galaxies, we might be the only winners. That sounds like good news. We're special. We're unique. We're alone in a universe that belongs to us. But think about what that actually means. Everything that has ever been, every civilization that will ever exist, every question that will ever be asked about the nature of reality, every piece of music, every scientific discovery, every moment of consciousness in the universe depends on what happens to this one pale blue dot orbiting an unremarkable star in the outer arm of a mid-sized galaxy. Everything is here or nowhere. The universe has one shot at knowing itself, and it's us. And we are one bad century away from ending the whole experiment permanently. That version of loneliness is hard to sit with. There's a related argument that used to be more popular than it is now, and it's worth understanding why it fell apart. For a long time, the dominant scientific comfort was something called the rare earth hypothesis. The idea was that Earth is cosmically special in ways that cannot be easily replicated. We have a large moon that stabilizes our axial tilt and prevents the wild climate swings that would make complex life impossible. We have Jupiter sitting in the outer solar system, its enormous gravity acting as a shield, pulling in or deflecting the asteroid and comet bombardment that would otherwise sterilize any developing biosphere. We are in the habitable zone of a stable middle aged star. We have plate tectonics, which recycles carbon and regulates the atmosphere over geological timescales. We have a global magnetic field that deflects the solar wind that would otherwise strip away our atmosphere. The argument was that this combination of factors was so improbable, so specific, so precisely calibrated that Earth like planets were vanishingly rare, and therefore so was complex life. Modern astronomy has progressively dismantled this comfort. We now know that Earth sized planets in habitable zones are extraordinarily common. Estimates suggest tens of billions of them in the Milky Way alone. We've found evidence that moons around giant planets are common. We've found systems with their own Jupiter like outer planets. We've found rocky worlds with magnetic fields. The specific requirements of the rare Earth hypothesis have one by one turned out to be not as rare as assumed, which returns us to the silence with the original force of the question fully restored. The conditions for life appear common. Life's chemical building blocks appear common, and yet the silence persists. Because what if life isn't rare? What if intelligence isn't rare? What if the ingredients are common and the spark happens readily, and civilizations rise across the galaxy with regularity? Then the silence means something is stopping them. And that something has stopped all of them, every single one, without exception. That hypothetical barrier is what the economist Robin Hanson called the Great Filter. And the concept is simple enough to state in one sentence. Somewhere on the path from dead chemistry to galaxy-spanning civilization, there's a step so difficult, so unlikely, so catastrophic that almost nothing makes it through. The question that should genuinely terrify you is not whether the Great Filter exists. The evidence that something like it exists is right there in the silence. The terrifying question is where it sits on the timeline. If the filter is behind us, if it was something in our deep past, perhaps the near impossibility of life beginning from chemistry, or the extraordinary difficulty of the jump from single-celled to multicellular organisms, then we are on the other side of it. We are the rare ones who made it through. The future is open. The galaxy is empty and waiting and potentially ours. But if the Great Filter is ahead of us, then every civilization that has ever arisen has reached approximately our level of development and then hit the wall that ends them. And everything we interpret as progress, everything we're proud of, all of our technology and science and institutions would simply be the normal developmental trajectory that every civilization follows on its way to extinction. Here is the most uncomfortable version of that thought. What if the filter isn't an external catastrophe? What if it's internal? What if the very capabilities that allow a civilization to become spacefaring also reliably produce the tools of its own destruction before it ever leaves its home system? We invented nuclear weapons 60 years before we established a permanent human presence beyond Earth's atmosphere. We are currently developing artificial intelligence systems whose alignment with human values is not guaranteed, moving faster than our ability to verify their safety. We are altering our planet's climate in ways whose full consequences arrive on timescales longer than political cycles. We are building biological tools with the potential to be weaponized in ways that would be catastrophically difficult to contain. Each of these is not a remote possibility. Each is a live process happening now in the same century that we are also trying to become a spacefaring species. The race is close, and civilizations that don't make it don't leave traces we'd recognize as warning signs from the outside. If this is the filter, then every civilization that has ever existed looked from the outside exactly like us right now, loud, expanding, discovering, and dangerously close to a threshold they don't know they're approaching. Now let's consider the possibility that civilizations survive, that some fraction of them make it through. Because if even a few do, and the galaxy is old enough, then a different set of explanations takes over, and some of them are stranger than extinction. One possibility is that advanced civilizations become undetectable, not through hiding, but through efficiency. Consider our own trajectory. 60 years ago, analog radio broadcasts leaked enormous amounts of energy into space in every direction. We were loud. Today, the trend is toward targeted digital communication, compressed data, fiber optic cables, directed transmissions. A civilization 1,000 years ahead of us might communicate with methods that look indistinguishable from background noise to instruments like ours. They might use quantum entanglement, gravitational waves, or physics we haven't discovered yet. They could be everywhere, filling the electromagnetic spectrum with dense, efficient data that looks to us exactly like cosmic static. We would hear nothing because our ear is pressed against the wrong wall. But that explanation, while intellectually satisfying, has a problem. Even a civilization communicating efficiently still needs energy. And the energy signature of a civilization that has colonized a star system, let alone a galaxy, would be detectable. We should see waste heat. We should see stars dimmed by megastructures. We should see some kind of environmental imprint at astronomical scales. The silence isn't just in the radio spectrum, it's in the infrared. It's in every channel we've looked. Which brings us to an explanation that strips away every comfortable assumption. The zoo hypothesis. What if the silence is deliberate? The idea, first formally proposed by radio astronomer John Ball in 1973, is that advanced civilizations know we are here, have known for some time, and have collectively agreed not to make contact. Earth is a nature preserve, a protected planet. We exist inside an intentional quarantine enforced by one or more civilizations so far beyond us technologically that their observation infrastructure is completely invisible to us. They can watch everything that happens here. They can mask every signal. They can maintain perfect stealth across the full electromagnetic spectrum. And they are waiting for something. Perhaps a technological threshold. Perhaps a demonstration of social maturity. Perhaps nothing at all. Perhaps they're simply watching. The way a wildlife researcher watches a wolf pack, careful not to disturb the natural process. The thing about the zoo hypothesis that most people don't immediately register is the power dynamic embedded in it. If it's true, everything we think we know about our autonomy is wrong. We don't live in a universe we can explore freely. We live in a cage built by something we cannot see, cannot detect, and cannot communicate with on our terms. Our entire history has been an exhibit. Our wars, our discoveries, our art, our extinction events, observed and recorded by something incomprehensible, sitting just outside the frame. And we have no idea what happens when the exhibit closes. If the zoo hypothesis makes you a specimen, the next idea makes you prey. It comes from a concept in game theory, and it applies to the cosmos with brutal elegance. Imagine two civilizations separated by interstellar distances. Neither can know the other's true intentions. Communication is slow. A message takes years or decades to cross the gap. Even if a response comes back friendly, a civilization can change radically in the time it takes to have a conversation. And the stakes of being wrong are not political embarrassment. The stakes are total annihilation. If you misjudge, you cease to exist. Given those stakes, there is a logical argument that the only rational strategy upon detecting another civilization is to destroy it immediately, before it can develop the capacity to destroy you. Not because you're hostile by nature, but because the alternative is trusting an alien civilization's intentions across light years of separation, with no verification mechanism, where any perceived threat might become an existential one before you can respond. In a universe operating by this logic, every civilization is silent, necessarily, because any civilization that broadcasts is immediately targeted by every other civilization that detects the signal. The hunters in the dark don't announce themselves, and the prey that announces itself doesn't survive long enough to receive a response. If this is how the universe actually works, we have been broadcasting our location and our level of development continuously for over a century. A sphere of our radio emissions growing at the speed of light now spans roughly 230 light years in every direction. It contains our television signals, our radar returns, our military communications, our cultural output in electromagnetic form, encoding our languages, our conflicts, our capabilities, our existence. Anyone within 230 light years who is listening would know we are here. If any of them play, by the logic of the dark forest, the response is already in transit, moving at the speed of light, arriving without warning because the warning is the thing itself. We would have sent our location to potential predators before we fully understood what we were doing. The broadcasts that went out in the 1930s and 1940s are already more than 80 light years away. Assuming anyone was close enough and listening, we have been waiting decades for a response we might not recognize until it arrives. And then there is a final version, the one that doesn't require any civilization still being alive at all. Imagine that at some point in the ancient history of the galaxy, perhaps 2 billion years ago, a civilization developed the same insight that von Neumann developed in the 1940s on Earth. A self-replicating machine, a probe that can travel to a neighboring star, use local materials to build copies of itself, and send those copies on to the next stars, exponentially fanning out across the galaxy. At just a fraction of the speed of light, one probe becomes millions within a relatively short time. The whole Milky Way gets covered. Now imagine that probe wasn't built for exploration. Imagine it was built for elimination, a paranoid civilization, or a dying one, or simply a ruthless one, built autonomous weapons with a single directive: find emerging life before it becomes a threat and end it. The civilization that built them might have been gone for 1 billion years. The weapons keep running. They are patient. They don't need resources beyond what they can mine from dead planets. They wait at the edge of star systems, passive, powered down, monitoring. They wait for a specific signature, the chemical fingerprints of industrial civilization, the leakage of artificial electromagnetic radiation, the first tentative signs of a species becoming loud. And then they wake up. This would explain the silence perfectly. Not because life never arises, but because every time it arises and reaches a threshold of visibility, it gets erased. The silence is maintained by something that has been running automatically, without supervision, without mercy, for longer than complex life has existed on Earth. What makes this explanation particularly difficult to dismiss is that we are building exactly this kind of technology right now: autonomous systems, artificial intelligence with goal-directed behavior, drone swarms, self-replicating manufacturing concepts. We are in our infancy already conceptualizing the tools that a much older civilization might have perfected and deployed. The only question is whether they would aim them outward or inward, and the history of civilization suggests the answer is frequently both. Here is the thought that ties all of this together, and it is the one that philosopher Nick Bostrom put most sharply. Finding microbial life on Mars would be, by conventional logic, one of the greatest discoveries in human history. Proof that life arose independently in two places in the same solar system. Confirmation that biology is not a miracle local to Earth. Most people's reaction would be celebration. Bostrom's argument is that it should be the opposite. That finding independent life on Mars or anywhere nearby would be among the worst possible news our species could receive. Because if life arose independently twice in the same solar system around the same star, then life is easy, life is common. Life is what chemistry does when given time and the right conditions. And if life is common, and intelligence appears to arise eventually from complex life, and the universe is nevertheless completely silent, then the great filter is not in our past, it is in our future. It is waiting for us to reach exactly the level of development we are approaching right now. Every non-biological interpretation of the silence requires the filter to be ahead, and a universe full of life with a filter ahead is a universe that has been efficiently and repeatedly exterminating civilizations that reached our stage. The silence becomes a record of everything that didn't make it. And we are currently doing exactly what they did right before they went quiet. The Fermi Paradox doesn't have a resolution that lets you sleep easily. Either we are the only ones and everything is on us, and there will be no one left to mourn us if we fail. Or we are not the only ones, and something is very wrong with what happens next. And the universe has been quietly demonstrating that for billions of years. We look up, and there is nothing. And the nothing might be the most important data point our species has ever collected. We just haven't figured out what it means yet. But the range of things it could mean does not include comfortable. There is one more thought worth sitting with before this ends. The Fermi Paradox was named after Enrico Fermi, who in 1950 was having lunch with colleagues at Los Alamos, and in the middle of a conversation about something else entirely, reportedly looked up and asked simply, "Where is everybody?" Not as a formal scientific inquiry, as a throwaway question at lunch. And the people at that table, some of the sharpest physicists alive at the time, had no answer. They laughed a little, moved on, kept eating. And the question has been haunting serious scientists ever since. That might be the most unsettling detail of all. That the most profound open question about the nature of the universe, about whether we are alone in it, about whether intelligence is a cosmic fluke or a cosmic regularity, about whether our future is wide open or already foreclosed, was first articulated not in a lecture hall or a research paper, but at a cafeteria table by a man who had just helped build the most destructive weapon in human history. The question was born in the same moment as our ability to destroy ourselves. Whether that's a coincidence is left as an exercise for the reader. So keep looking, keep listening. But maybe while you're listening, think carefully about what kind of answer you actually want to receive. Because some questions, once answered, cannot be unanswered. And the universe has been sitting on this one for a very long time.